In this lecture, let's review the rules for interpreting condensed formulas in organic chemistry, including converting Lewis structures into condensed formulas and vice versa. Before beginning, let's review the common bonding patterns. I'll refer you to my other lectures on common bonding patterns for elements encountered in organic chemistry. I'll give a brief summary here. Neutral carbon will have 4 bonds. These can be 4 single bonds, 2 single bonds and a double bond, or a single bond and a triple bond. Neutral nitrogen will have 3 bonds and a lone pair of electrons. This can be 3 single bonds and a lone pair, a single bond and a double bond and a lone pair, or a triple bond and a lone pair. Neutral oxygen will have 2 bonds and 2 lone pairs of electrons. This can be 2 single bonds and 2 lone pairs, or a double bond and 2 lone pairs. Finally, the halogens, which include fluorine, chlorine, bromine, and iodine, will typically bond only one way, a single bond with the halogen atom having 3 lone pairs. Interestingly, hydrogen, which follows the duet rule, it can only have 2 valence electrons, will also participate in only one single bond, but have 0 lone pairs. Now, let's do some examples. Let's convert this condensed formula to a Lewis structure. We've seen this already. When you have groups of atoms in parentheses at the beginning of a condensed formula, this typically means that these groups are bonded to the first carbon atom in this chain here. So for this carbon atom, I'll go ahead and draw it right here. And then around this carbon atom, there are these 2 methyl groups, or CH3s. And then after this carbon atom, we have the hydrogen. So that gives this carbon 3 bonds. These carbon atoms in these Lewis structures want to have 4 bonds to complete the octet. So we'll continue the chain here. So this carbon atom is bonded to the next carbon atom. And that carbon atom is bonded to the 2 hydrogen atoms. And then at the end here, we see this OH group. And so this is the alcohol functional group. To convert to Lewis structures, we have to understand the bonding patterns. For oxygen, the bonding pattern is 2 bonds and 2 lone pairs for neutral oxygen. So we'll continue the chain here. So now this carbon satisfies the octet rule. And then on the other side of the oxygen, we'll draw the hydrogen. For Lewis structures, I'll go ahead and add the 2 lone pairs. And so this is the conversion of this condensed formula into this Lewis structure. And we have the alcohol functional group. Let's convert this Lewis structure into a condensed formula. You'll notice there are 3 alcohol functional groups. And starting on the left side, we see the alcohol group written with the hydrogen first. This is typical when you see alcohols written on the left side of a condensed formula or even a line bond structure. The significance here is that we start with the hydrogen, and then this goes bonded to the oxygen, which of course then goes bonded to that first carbon in the chain. So for condensed formulas, when you start with an alcohol, we usually write the HO first and then continue on with the carbon. So here we have a CH2, another CH2, and right here we see something interesting, some branching happening. So in this chain, this carbon is bonded to another carbon and an oxygen. So the way we'll write this here is after this carbon, we'll write the hydrogen, that's this hydrogen, and then we have to write that this carbon is also bonded to this group of atoms. And so when we have a group of atoms, we'll write those in parentheses. The parentheses signifies that this group is bonded to the previous carbon. And then after this, we'll continue with this CH2 group right here. And finally, at the end, our OH group. Let's convert this condensed formula into a Lewis structure. The first thing I'll notice here is we have this carbon chain. We have that OH group at the end. This is the alcohol functional group. And I also see this heteroatom. Hetero means an atom other than carbon and hydrogen. This is an oxygen. Notice that the oxygen isn't bonded to a hydrogen like it is here. That means that this oxygen is going to be within this chain. This is called an ether functional group. So let's draw this. We'll start on the left side. Here's the CH3. The CH3 is bonded to these two methylene groups. In parentheses, when you see the CH2, that means that these are two methylene groups that continue the chain. And it's important to follow the bonding patterns. So how do we know this is an ether functional group? Well, when we see this right here, the carbon atom has 3 bonds. We want to give it 4 bonds. The bonding pattern for carbon is that it's neutral when it has 4 bonds. And so there's the oxygen. This completes the octet here. We also know the bonding pattern for oxygen. It has 2 bonds and 2 lone pairs for neutral oxygen. And so here we'll give oxygen the second bond, and this goes out to these 2 methylene groups. And for oxygen, I'll come back here, give it its 2 lone pairs. So the octet rule is satisfied here. And of course, at the end, we'll complete the octet for this carbon by giving it the 4th bond to the oxygen, and we'll close up the oxygen with that bond to the hydrogen. And so here's our alcohol functional group. And then right here in the middle, we have the ether functional group. Let's convert this Lewis structure into a condensed formula. In this case, I've given you an ether functional group here. I've also included the alkyl halide. We've seen these before in a previous video. So let's draw the condensed formula. I'll start on the left side. Here's the CH3 group. This is bonded to the methylene group, the CH2. And then right here, we have this carbon that's bonded to a hydrogen and bonded to a chlorine. Now, a special note here, here's the chlorine. If you look at organic chemistry books, I've seen this 2 ways. You can leave the chlorine the way it is. Of course, if you know the bonding patterns for these halides, they can only form the one bond. So this chlorine will not be in the middle of a chain. So it's assumed chlorine, like hydrogen, is bonded to the previous carbon. However, in some textbooks, I have seen this example where the chlorine or the halogen is in parentheses. Of course, this parentheses would mean that the chlorine is bonded to the previous carbon. So when you see this parentheses, that's what that means, although the parentheses don't have to be there. I'll go ahead and leave them there for now. Next in the chain, we have the CH2 group, followed by the oxygen. The oxygen is not bonded to anything else other than this last group here, so then we'll just add that CH3 group at the end. So we have the alkyl halide and the ether.